Hi everyone, in this short tutorial we'll try to explain the concept of projectile motion and showing the integrations needed to reach the equation of trajectory. A point mass is being launched with an initial velocity v0 and an angle alpha, as you can see on the free body diagram. The only force acting on the object is its weight, neglecting all friction type forces. Applying Newton's second law, we can say that the sum of the forces will be equal to m times a. So mg will be equal to ma. We can cancel m and we will get a equal to g vector. Since g is directed vertically downward, then the result will be a equal to minus gj. As you can see on the figure, the object will be just moving along in a projectile, and v will be always made up of two components during its motion, unless if we are talking about the maximum point. And now let's start with v, integrating from a to v. This is the result that we have reached from the previous slide. Now we can just integrate a to v, and simply here we can just add t, or increase the power of t. How can we do that? Here a equals to minus gj, so we must multiply by t and it will be minus g tj, or we can increase the power of t. Here t is t to the power 0. Assuming that here t is to the power 0, we can add it to be t to the power 1 and divide by 1. Always we must add the constant, so v, we add v0. Later on for r, we add r0. But what is v0? If we just take a look on the graph, we can see that the initial velocity is made up of two components, an x component, and since alpha is shown, or the angle, we can just use cosine to find the x component. And for the y component, since the angle is not shown here, we can use sine. So v0y will be equal to v0 sine alpha. Substituting the value of v0 will look like v0x and v0y, and then we can add up the j components together to reach this yellow formula. Now from v we can integrate to get r. So now we can write this part and do some integrations, and remember the rule that we just add the power of t and divide by that power. So starting from the x component of v, since t is to the power 0 here, or it's not shown at all, we can just add t to be t to the power 1. On the other side, here t is to the power 1, we can add the power to be t square, and as usual we divide by the power, so it's half gt square. So always and always are just adding the power and dividing by that power. For the sine alpha, for v0 sine alpha, there is no t, so it's t to the power 0. We can add it to be t to the power 1 and divide by 1. The parametric equations always use the result for the previous part, or r0. So here we didn't add r0 at all, since r0 represents the initial position and the object is being launched from the 0, 0, or x equals 0 and y equals 0, from the origin mainly. From r we can take this component, which is x, and this component, which is y, and we can do some calculations to find the equation of trajectory. So x and y represents the parametric equations, and substituting t from the first equation, so t will be x over v0 cosine alpha. Substitute this value in y, and we will get this equation. Finally, after doing some math, we can reach the shape of y equal minus g x square over 2v0 square cosine square alpha plus x tangent alpha. And this equation is parabola, since it looks like y equal ax square plus bx plus c. Thank you.